All right. Good afternoon, everyone. So I hope all of you has been going through our lecture video on the topics of learning Unit 5, digital and analog transmission. So this session, I'm going to give you some of the basic, or say the summary of what are the aspect that you should be paying more attention. Okay, let me. All right. Set a little bit. Get the chat. Okay, so this topic is very much about digital and analog transmission. So I would say, throughout the entire transmission, the whole purpose of what you want to deliver, what are we transmitting, is all basically our data. Okay, as I mentioned in the early learning units, so anything generated by a computer's related type of system is actually digital data. For example, your picture in JPEG, your MP3 file, your Excel file, your document file, your PowerPoint, and all the stuff. Those are actually digital data, and they take the format of 1 and 0. But when you want to actually deliver, transmit this digital data from one device to another device, then you will probably need to convert this digital data of 1 and 0 into a transmittable format. So you need to convert it into a digital signal for the first stage, digital signal. So we have to convert it into a digital signal so that it can be carried by the electrical signal. So the electrical signal, for example, DC, that has been used to represent 1 and 0. So you have to convert it into that particular format. Otherwise, it cannot be transmitted from one device to another device. And then digital signal can only give us a very short distance of transmission. You have to always remember this. Inside your computer system, some of the components are actually close to each other within maybe just tens of centimeters. So your cables can be just like maybe 1.5 meter maximum, or maybe less than 1 meter. So you can still use that digital signal to actually send your digital data. But first, you have to convert your digital data into digital signal. So that is the rules. You cannot just deliver digital data directly to another device through a cable, just like that, you see. So you need to convert it to digital data. So that electrical signal, such as your voltage and current, can be used to transport the data, right? So that is the rules that you have to understand. The most principal understanding about digital data and digital signal, right? So if you want to transfer your digital data to a longer distance, for example, into the internet, into a computer network, and a computer network is actually separated by maybe tens of meters, hundreds of meters. And then if you talk about the internet, it's actually transmit over the whole world. You see? So if you want your data to be able to go this distance, a longer distance, that is go outside of your computer system, then you have to convert your digital data into an analog signal. It is not to say convert, I would say to integrate your digital signal into upgrade your digital signal to an analog signal, so that this analog signal will be able to travel a longer distance to bring your data over a longer distance. So digital data, digital signal, analog signal, so they all take their place. Digital data happen within your computer system itself. So if you are actually transmitting your data over a short distance, for example, only up to a few meters, for example, you are using a USB cable, okay? You are using a USB cable to transmit your data, to send to your printer, these are short distance. So you can still just use digital signal. But if you want to deliver your data, transmit your data over a longer distance, which is over a computer network, then you have to put your digital signal onto an analog signal so that they can travel a long distance. So you can use that analog signal as a transport for your digital signal, right? So you have to combine them. Just like I mentioned to you before, you get on the bus, you want to travel for a long distance, you cannot just walk, you see. By walking, you won't go too far. But if you can make use of a mean of transport, such as a car or a bus or a train, then you can go a very long distance. So this car, train, bus, this is actually the analog signal, right? So that is actually the difference between the three. So you got to be clear about their purpose. So you don't just say, okay, digital data and digital signal are same thing. No, digital data is just digital representation of data, which is 1 and 0. And digital signal is to represent 1 and signal using voltage, 5 volt, 0 volt, all the stuff, right? To represent, using signal to represent 1 and 0, so that this signal can carry your data over the transmission path. And analog is what? Analog is actually a medium. So where you put your digital signal, combine them together, and then the process of combining is what we call modulation. So you modulate the two, digital and analog, together, so they will join to become one signal, and then this composite signal will be able to travel a longer distance. Okay, so those are the basic principles that you will have to be very clear in the beginning of this session here. Right, so this is just like what I'm talking about. Original source, digital data is 1 and 0. Whatever that you store inside your hard disk drive, whatever they store inside your USB drive, they all take places of 1 and 0. But for you to transmit them, you need to use a signal. So this signal is going to be an electrical signal. So electrical signal come with voltage and current. So what you're going to do is actually try to use the voltage and current to represent 1 and 0. The moment when you do that, then you actually produces digital signal. All right. So I hope you can understand the differences now. So as what you can see from the this diagram over here. Oh, sorry. Where is that thing? Okay. Where am I now? Sorry. I think I clicked the wrong thing. Okay, and I should be clicking this one. Yeah, I should be doing this. Okay, so you will see this diagram here. This is actually how you, your 1 and 0 is being represented by a digital signal. So this signal going up and down, you can see this signal going up and down. This is actually a digital signal. Okay, this one is actually a digital signal, right? So for analog signal, that will actually carry. So when you actually modulate the digital signal to analog signal, this is what you're going to get. So this is an analog signal that has already has integrated, modulated with digital signal. That's why you can still 0 and 1 here. All the 0, all the 1, everything is here. Right? You can still have the 0 and 1. So this is actually the differences. So this part you've got to be very, very clear. Right? Analog signal can travel a long distance. That is the nature. Why? Higher frequency, okay? Higher power as well, higher power signal. And digital signal, usually DC, right? DC usually lower power, short distance, right? So those are actually the rules, the concept that you already have to grab. Okay, and then there are different representation of digital signal. Okay, how do you produce digital signal here? Okay, so when you have digital signal, okay, they will take a line coding scheme. You need a line coding scheme. This line coding scheme here will actually the process of for you to create your digital signal from digital data. So these are the scheme, what we call line coding. And there are different type of line coding schemes such as unipolar, polar, and bipolar. These are the three basic schemes. Okay, the most basic scheme that you can actually use to convert digital data to digital signal. Right, and then after you have actually convert them, then they will actually produce the digital signal. Then how about analog data? For example, now I'm talking to a computer. Now I'm talking to a computer and my voice is an analog voice. So, but you guys listen over the other end. And my voice actually travel through the internet. And you know that the internet is a computer network. So how can an analog data, such as my voice, can actually travel across the digital medium? So there's a process called what we call the analog data to digital signal conversion. Okay, so I'll just highlight this part. And then the technique that we usually use to convert analog data, such as voice, my voice analog, using a microphone, okay, these are all analog. So we are using a technique called pulse code modulation, PCM. Okay, inside PCM, we will have three processes. One is sampling, the other one is quantization, the other one is encoding. So this PCM involves three different processes. So to me, for this entire learning unit, this part is very important. This slide is actually extremely important. Why? Because this slide basically gives you the overall concept. And once you understand this overall concept, later when you look at each of these details, it will be very easy for you to understand. Right? So, and then digital signal, they also come in different transmission mode. When you have got a digital signal, so what are the methods for you to transmit them? They can be in parallel or in serial. Or what is parallel? Parallel use actually multiple cable. Okay, you got 8 bits. Your data got 8 bits, right? 10110001, 8 bit. So you want to transfer this 8 bit, you can use 8 cable. One cable carry 1 bit. So in one cycle of transfer, all the 8 bits can be transferred at once in parallel. So this type of cable, we call them ribbon cable, or what we call the parallel cable. So it looks like a ribbon cable that has got multiple cables running in parallel. So those kind is actually what we call parallel. But today, the serial transmission mode is more, I would say, is more popular. Serial transmission mode, such as your USB cable. You see your USB cable one is actually very simple. It actually consists of 2 cables on the inside. Okay, serial transmission usually involve only 2 cables. Okay, one is for signal, the other one is for grounding. So if you look at your USB cable, they are quite small, quite thin, as compared to the parallel cable, which is quite flat. You can see multiple color. This something like a ribbon, quite wide. So I mean, to your understanding, I think you are actually learning this in your computer architecture as well. So which one can perform better? Then you may say, of course, the parallel one. You know why? Because parallel got more land. They can deliver more data in one cycle. Yes, correct. But they also have challenges. Right? Each of the cables has to be perfectly equal, but most of the time they are not equal. So as long as certain cables start to cause problem, then your parallel transmission will experience a lot of errors. That's why in today's standard, parallel transmission, people start to upgrade it to serial transmission. Why serial transmission using 2 cables only, and then they send data in series? This means you have 10110010. So this 8 bit will be sent bit by bit through a serial cable. And then using a serial cable, you can actually increase the performance by increasing the speed. Okay, increasing the speed of the clock. Serial transmission in the clock. So you increase the clock speed, so your data can increase just like that. So, and then less error being experienced on the serial transmission as compared to a parallel transmission. You still remember last time when we are connecting a hard disk drive, we are always using parallel cable. But today, we are using a serial cable. That's why we call our hard disk connection cable called SATA cable. Okay, SATA, SATA. SATA, the S stands for serial. But before that, when we were using parallel cable, and then parallel cable, we call it PATA, P-A-T-A. P stands for parallel. It's using a serial ATA or using a parallel ATA. So before this, the older version is using parallel ATA, but the new one using serial ATA, which is called SATA. So every time we encounter the word for hard disk drive like SATA, this is always referred to the digital signal transmission mode that they use. It is actually using a serial transmission. And one typical example is your USB cable. All your USB cable connecting to various set of devices that you have, they are all in serial transmission mode. And in terms of performance, serial transmission mode can outperform parallel easily. Why? because the error handling on the serial is actually much easier. And for it to improve performance, they just need to increase the clock speed at both ends. So you engage a higher performance processor with a higher clock speed. So then your performance can be increased just like that, you see, using just 2 cables. That's why serial transmission mode nowadays is a higher performance transmission, and they come with less error as well. So it is the most popular one at the moment. Okay, so I hope you get it. And then this is also another important slide here. So in analog transmission, when you are actually transmitting your digital data over analog signal, because you want to go for a longer distance, so you have to carry out with this digital to analog conversion here. Okay? Your data is actually in the digital, but now you want to send it using an analog transmission signal. So you have to do a digital to analog conversion. So these are the common technique that we always see. It's like amplitude shift keying, frequency shift keying, phase shift keying, ASK, FSK, PSK. Anything if you hear the word keying, if you hear the word keying is always referring to digital. Okay, digital. It has something it has something related to the digital conversion. So anything you see amplitude shift keying is actually digital to analog conversion. And of course, there is another type, what we call the analog. If your data is analog, just like my voice, okay, if my voice now over the microphone, for example, if I'm a radio station DJ, okay, I'm a radio station DJ now, I broadcast my voice using FM, right? My voice is analog, but my broadcast that I'm using is FM, okay, which is frequency modulation. So it's also an analog transmission, an analog signal. So it's analog to analog conversion. So if I want to broadcast my voice, I'm a DJ, I'm a singer, I sing over the air, people say, I sing over the air, then they broadcast my voice over the FM radio transmission. Then this is actually an example of analog to analog conversion. So your data is analog, so you just use some of this technique called either amplitude modulation, frequency modulation, or phase modulation. You don't see any keying at the back. Every time when you see keying, that actually refer to digital to analog. Analog to analog is always history, AM, FM, PM. Okay, so when you see ASK, FSK, PSK, these are all referred to digital to analog conversion. And the technique that they use for ASK, amplitude shift keying, and the amplitude modulation is actually very similar. So it's changing the amplitude, the other one changing the frequency, the other one changing the phase. Okay? Frequency modulation, change the phase. Frequency shift keying, also changing the frequency. Frequency modulation, changing the frequency. Frequency shift keying, also changing the frequency. Right? So you have 3 components that you can change for you to do the 3 different types of conversion. Amplitude, frequency, and phase. Right? So both apply to different conversion, digital to analog or analog to analog. Right. So the whole idea why people want to, at the end of the day, they want to produce an analog signal is because this analog signal can travel a very long distance. For example, when you listen to FM radio broadcast, right? I mean, your favorite radio channel, your favorite DJ, when they actually talk over the air, over the FM, so it is actually over a very long distance. Okay, so if the voice is not being encoded into an analog signal, such as using FM or AM or even PM, then your voice won't be able to travel such a distance. Right? So the whole idea, at the end of the day, long distance always involve analog signal. So that is the thing that you always have to remember. Okay, so I think just now the 3 slides before this are actually extremely important because it's actually pen and very high level overview of your understanding. If you understand the 3 slides before, I think for the rest of the slide here, things are going to be very straightforward because these are the details that we are talking about, right? So when we do digital conversion in the digital transmission, so you can see what is happening. We have to use line coding to convert the digital data to digital signal. And then the technique is called line coding. Line coding. The technique is called line coding. Digital data to digital signal. So you use line coding scheme. So what are the scheme? One of the scheme is actually here. It's not here, sorry. One of the scheme is actually unipolar, polar, and bipolar. Right, so those are the three very basic type of scheme. And they just basically using different signal representation to represent the same 1 and 0. So for unipolar, it's very simple. Uni is actually, uni refer to one, okay? Only one polar. This means it's only one polarity, right? One polarity only. This case here, if it is a 1, then you get this line here, okay, which is actually, let's say this one is actually 5 volt. That's right here, 5 volt. Okay, this one is 5 volt, and then this one is 0 volt. Okay, a 0 will actually get a 0 volt. And a 1 will actually get a 5 volt. As simple as that. And you don't have negative value because this is unipolar, using one polarity. So you only have 5 only, or 0. Okay, 5 and 0. So don't have. So this is actually probably the most simple type of line coding. And then, of course, there are actually some of the techniques called polar. The polar type of line coding using 2 voltage level, positive and negative. So that's polar. So under polar, they got different type again. They got non-return 0, return 0, and they got Manchester. Okay, they got differential Manchester. Okay, different type of technique here. They're using 2 polarity, positive and negative. So we just use example like this. This is actually one example of a non-return 0. See, this is positive 5. This is positive 5 volt. And then this one here, over here, this is negative 5 volt. Okay, so 0 refer to a positive value, positive 5 volt, and then a 1 refer to a negative 5 volt. This is not 0. This is not 0. They don't like to use 0. Okay, so they want to make it much more, much more clearer. So the representation is actually much more clearer using this type of technique. Okay, so they are using 2 polarity, positive and negative. Right. So they can even use the return 0 type of encoding. You see half of it here are actually at 0. So every time there is a transition from 1 to 0, there is always a return to 0. So this is just technique, okay? You may ask, what's the advantage of these techniques? The advantage of this thing compared to the one previously is actually this one is more tolerable to error. Less error is going to happen. Okay? Because when you actually use a signal to carry your 1 and 0, sometimes, distortion and error happen along the way, isn't it? So how do you detect errors? So that's why you must use a more robust technique to represent your 1 and 0. So that you can easily tell, even if error come into the picture, you will be able to easily tell there is an error. Okay? So some of the more complicated techniques are actually trying to minimize the chances for error throughout the transmission. Right? So I hope you can understand. And there's also another issue when you actually send things, another issue with synchronization. Okay, out of sync. If you look at this one, see, there's a gap here. See, there's a gap here. So this is actually out of sync. This one also out of sync. So this out of sync can be a problem. Can be a problem. So it will actually give you some error data. So out of sync. What does it mean? Sync. So it's actually the timing between the sender and the receiver. Okay, is not matched. Timing is not matched. That's why we call it out of synchronization. When I speak, but you are not listening. Okay, when I speak, but you are not listening, then we are out of synchronization. You will miss what I'm saying. For example, if I'm saying something now, then you suddenly leave and to go to the toilet for a while. So we are out of sync. Whatever I said, you won't hear, you see, you won't get it. So this is what we call out of sync. So our timing is not correct. When I say something, you are not ready to listen. So this is what we call out of sync. So this thing could happen to any of the digital transmission as well. So there are many different types of techniques. For example, this one is the Manchester encoding. It's a Manchester encoding. So they use the transition of this one. Maybe I should change the color of my pen. Pen color. Change to blue one, for example. Okay, when I change the blue one, you can see this part. This is actually the part that is being used to indicate there is a change in 1 and 0. So that's why you can see 0 is based on this. 0 is like this. When the thing is like this, there is a 1. Right? So the way they represent 0 and 1 is slightly different. And then the whole idea is this Manchester encoding can provide synchronization information. Right? So they can provide synchronization information so that they won't miss, they won't get confused. Okay, this is what this one bit belongs to who, and so on and so forth. So line coding technique is going to get more and more complicated. And the more complicated one is the one is more robust against noise and distortion coming from the channel along the way. Okay. So this is another one. It's called the bipolar. Another type of bipolar. But I will not explain too much here. But the whole idea is that I would like you to understand. These are all the different line coding. The complicated one will actually be able to do more things. For example, they included the synchronization information as compared to the simple one. And the simple one do not have such information. That's why they will run into problems such as, missynchronization. Right. Now talking about the analog data such as my voice. So you want to actually convert my voice, send my voice into the internet. So there are processes that you have to do. That's involving 3 processes for sampling, quantizing, and encoding. Okay, and then the sampling process, usually we call it the pulse amplitude modulation, PAM. Okay, so that is actually a sampling process. So you look at this diagram. This diagram is extremely good here. So this is my voice here. Okay, my voice. My voice is actually this signal. This is an analog signal. So I want to convert them into this format, which is a digital data from here all the way to here. I must go through this process called the PCM, pulse chord modulation. So this PCM encoder is going to carry out this PCM process. So inside this PCM process, we have 3 processes here. One is sampling, the other one is quantizing, and the last one is encoding. Right. So after you do the sampling, you are producing the PAM signal, the pulse amplitude modulation signal, before you send into quantization. So when you go through the quantization process here, okay, so you'll produce a quantized signal, and then later you pass it to encoding. So this is exactly the process. So if you look at the pulse amplitude modulation process, your analog signal here, this is analog. This signal here is analog. So you are going creating a similar signal here, which is in digital. The PAM signal is something like the digital, but they come in different value. You can see that this guy is over here, this guy is over here, over here, over here, and over here, over here. So you can see this guy is literally, this is actually same. See, it's the same shape as the original analog signal, but they just split it and given it a different value. So now your value is here, here. Okay, you can draw circle here and here lah. So these are the small circle of value derived from the original analog signal. So that so that the shape is more or less the same, but the data that they're taking is actually reduced. So sampling. So what the sampling rate, the higher sampling rate or the low sampling rate, you'll be able to see the difference. So low one, you can see this part is actually get quite big. Okay, the sampling size is quite big. The higher sampling one, if you look at this one, it's actually quite small. Okay, they are quite small. So high sampling rate is actually good because they can preserve a lot of your data as much as possible as compared to low sampling rate. That's why you want to have high quality, so you need to have very high sampling rate. For example, your high resolution audio will have 24-bit. Okay, and then your CD audio 16-bit. So these are the things that we have to pay attention to. So if you want your digital recording, after you convert them into digital signal, then they go by the number of bits. The higher the bits, the higher the resolution, the better the quality that you can preserve. Right. So if you look at the diagram below here, original waveform is very smooth, very smooth. But when you're actually using 2-point sampling, 6-point, see 2-point is like this only, So the shape is look so very, very squarish, right? Compared to 6-point, compared to 10-point. See, when 6-point is more smooth than the 2-point, and then the 10-point is even smoother as compared to the 6-point. Right. So the whole idea is about resolution is that if you want to preserve as much quality as possible, so you already have to use a higher bit rate. For example, 16-bit, 24 bits. Right? They will be able to preserve the original signal very well. Okay. So this is actually the example of quantization. So this is actually the what we call the signal itself, but we sample at a specific location. For example, here, in the fixed interval. So you can see that different value has been generated. This is 24, this is 38, and so on and so forth. So from there, we actually further convert them into a different value. This is how the process is happening. Right? So here I'm just showing you how this process is being carried out. Right? So you can see 5 level compared to 10 level, which one is better? Which ones look smoother? Of course, the 10 level one. So when you have 10 level, then your resolution is higher. Okay, and then when it comes to encoding, you need to encode them before you can actually send them. Right? So if they are 256 level has been used in the equalization process, then you need 8 bits to do the binary encoding, to convert each level to a binary value. So this encoding is convert the value here. This is plus 24. You can see the plus 24 here compared to this one. See? This is the plus 24. So you need to convert this 24 value into 1 and 0 again. See? So this is the 1 and 0 that you are getting for plus 24. Okay, if the value is plus 38, then there's a different value again. Okay, and so on and so forth. So this is the process what we call binary encoding. You encode the decimal value and then put it into a digital value. And this is exactly what it looks like. So plus 24, this is the value that you have. They're using 8 bits to represent. And then later the next one is plus 38. Another 8 bit to represent. Okay, so this is very straightforward. So I think this one you do not have much of a problem. And if you look at the entire process of overall, my voice here, have to go to a pen modulation, and then go to quantization, and then go to binary encoding before we can produce the binary data. And then this is the data that we want to send Once we got the binary data, then we can use the line coding technique to produce the digital signal. And then this digital signal will later be modulated to a digital analog signal. Okay, analog signal. So this is the entire process. So I just want you to be clear about the higher view of this processing. Okay, transmission mode, as I mentioned, straightforward, parallel using multiple cable. Okay, so that's why last time the printer are all using parallel cable, and your hard disk drive also using parallel cables for the data transmission. But nowadays they are just not popular. The serial transmission has overtaking, and they got two different types. One is synchronous, the other one is asynchronous. The synchronous is actually run on fixed timing. You must understand, serial is sending one by one, so timing is very important. So for example, when you're coming to class as well, let's say we have lectures at 2 o'clock here. So you must come at the right time, see. So your timing and my timing has to be correct. So you come at the right time when we are actually doing it. Then that is correct, right? So the one will come with fixed timing is called the synchronous, right? The one do not come with fixed timing is called the asynchronous. You can also come anytime to come and visit me, asking me for questions. So that is asynchronous. But if you want to ask questions during the class, you have to follow the class timetable, the class fixed timing, come to the class during that hours, then you will be able to ask me questions. So that particular mode is called synchronous mode. Asynchronous means anytime you think of a question, you want to ask me a question, then you just come to my office. Okay? You come anytime to my office and I will entertain you because there is no fixed timing. And this type of transmission mode, this type of mode, we call it asynchronous mode. So I think you can get this clear. And parallel, again, 8 bit of data, you need 8 cable, 8 lines to actually send. But if one of the line has got problem, for example, this one got problem, so everything will be scrapped, right? Everything sent together will be scrapped and here to be sent again. And the chances for this 8 line to pick up error is higher than just 2 line pick up errors, right? So more problematic, the way I want to say is using parallel transmission, using more lines in your transmission is actually much more problematic. And then today's modern transmission mode is actually serial, right? It's always actually serials. For what reason? Less error and higher performance. Your performance can be increased by just upgrading the clock used at the sender and the receiver. Just like that only, okay? Then you will get increase of performance. But for parallel, they are much more problematic. Chances for them to pick up error is very high. That's why they are less popular now. Okay? And the serial is like this. This is the data that you wanted to send. So they send in serial. And when they receive it, they put it back to parallel again. So it's as simple as that. Okay? Just don't get yourself confused. Okay, these are also some other examples. They employed the start and stop bit to maintain the synchronization. Okay, same thing. So analog transmission. Talking about analog transmission is actually a long distance transmission. So what are the things that require long distance transmission? Your computer data, right? When your computer data needs to travel into the internet, which is actually a long distance transmission. So you need to do the conversion, digital to analog conversion first. Because all the networking devices, when they interconnect using cable, they are all running on analog signal. Okay? Digital signal cannot go too far. That is actually, if we go back to science, you can imagine. If you are using a power coming out from a battery, okay, your battery is called DC battery, DC and direct current. And then your power supply by Tenaga, by Sarawak Energy, coming to your house, give you power supply so that you can run your lights and all the things, watch TV and all the stuff. So those power actually come in signal wave, sine wave. People call it alternating current. Why we have two different types of power supply? One is running on DC, the other one is running on AC. But to be honest, all your electronic appliances, such as your TV, your computer, your smartphone, a lot of these devices, they all run on DC. But if actually most of our home appliances are running on DC, then why would Tenaga la, Sarawak Energy la, give us power supply in AC? It is not matching. In fact, we have to do conversion before we can use our this energy supply by the utility provider. If you look at your laptop has got a brick, right? This is actually called an adapter, right? And if you look at your smartphone, when you want to charge your smartphone, you need to have a charger, right? So if without that charger, you cannot charge directly from the 3-pin plug, isn't it? You plug in, it's going to explode. Why? Because one is AC and your smart device requires DC. And your computer also requires DC. Your TV need DC. Your microwave oven run on DC as well. Anything to deal with electronic circuit is all DC. And then because of that, we need to do conversion. So the reason behind this, why I want to bring up this topic is because analog is like AC. Digital is like DC. Okay? So analog can go a long distance. You know where are the power plant of your utility supplier? Where are the Tenaga and Sarawak Energy power plant? Those are the power, the hydropower dam, which is actually maybe hundreds of kilometers away. They are very far. But how do they deliver power to us? Using cable, right? You can see all the cable hanging around. But they cannot run on DC. Those cables cannot run on DC. DC can never do long distance. So they have to produce AC, pump the AC into those power line, a long distance power line, hundreds of kilometers. So when they actually arrive at your home, then you have to convert them back to DC. Because AC analog is always good for transmission. Long distance transmission. And digital, sometimes we call it direct current, using DC power. They cannot travel very long distance. So they are all interrelated. Your knowledge is all interrelated. That's why for our signal here, same thing. Analog signal will travel a long distance. Digital signal cannot. So digital signal must be combined with analog signal so that they can be carried by analog signal to travel a long distance. So that's the whole idea. The entire network running on frequency. Whether you are using cable, you are using wireless, they all run on a high frequency, run on the transmission medium, either on the cable or on the wireless medium. Right? So those type of things, you can see all the sine wave here that you are seeing, all the sine wave here. These are all the characteristic of the analog signal. Okay? So you have your data over here, your message. Your message not necessarily has to be analog. You can have 1 and 0 as well. Okay? You can have different type of data to be sent into a modulator. But the transport now, which is what we call the carrier signal or carrier frequency, this is actually the transport now, just like a bus or like a train, like an aeroplane. So this is actually a carrier. The one that is going to carry your data. So they go through a process called modulation. This modulation is something like a platform, like you bought your aeroplane, you have to go to the airport. So this modulation process happen in a modulator. So it's similar to a process that you get on. You want to take a train, you have to go to the platform, the train platform. You want to take a bus, you have to go to the bus stop, right? So exactly the same thing here. This is where your signal boarding into the carrier signal. Then this is the outcome. The modulated signal is actually the outcome. You see, this is the outcome of the modulation process, which is actually consists. If you look at this modulated signal here, inside there, they actually consist of both signal, your message plus your carrier together. All right. So that is actually straightforward. And they have to go through the same process again. This one, I think we have done this before. This one is like a digital signal. This is the digital signal. And then you go through the modulation or digital modulation or analog modulation. Then you will get the what we call the composite signal, which is in analog format. So same thing here, your digital data go through modulator, then being carried by this analog signal. And then when you arrive at destination, you have to reverse the process to carry out a demodulation by a demodulator. So modulate, then later you must get off the platform, right? You must get off the bus, get off the plane. So that process is actually the reverse process of modulation. Then you will recover your digital data, which understood by your computer. Okay, so as straightforward as that. You just have to remember why we have to do so much of conversion. It is because of the nature of the data that we have is not suitable. It's actually not suitable for certain type of transmission. That's why we have to convert them. And then the conversion process, sometimes it's called the modulations, sometimes it's called encoding. Okay? So these are actually the different names for the different conversion process. All right, so when you actually sending computer data, you have digital data, isn't it? So when you send computer data into a network, then the process is called the digital to analog conversion. And then the technique is always come with the word shift keying. When you see the word shift keying, this is actually a technique that is used to convert digital data to analog. And then another one that is more popular is called the QAM, Quadrature Amplitude Modulation. QAM has been used widely in digital transmission, which involving, of course, this digital to analog conversions. So these are actually the technique I think that is being shown. So this is one example. When you see amplitude shift keying, the name amplitude tell you what? When you hear the name, it's amplitude shift keying. So you are going to play around with the amplitude, right? So what is amplitude? Amplitude is the height of your signal. You see this one got low amplitude. You see this one is very low. Okay? And then you look at this one is very high. This signal is very high. Right? High and low, the signal, the amplitude. The height of the signal is called the amplitude. So you are changing the amplitude to represent 1 and 0. Low amplitude represent 0. High amplitude represent 1. That's why you can see this one. Low, high, low, high, low. So it's 0, 1, 0, 1, 0. Right? So that is very easy. When you hear the word amplitude shift keying, the technique itself is manipulating the amplitude of the signal to represent 1 and 0. Okay? And then the same thing, this is actually the implementation process, which I don't want to explain here. I think in my lectures video, I explain it well. And if you look at frequency shift keying, now frequency shift keying, what are you playing with? You play with frequency. So what is a frequency? Frequency also got high and low frequency, right? So you can see this one is actually a low frequency. This is a high frequency, right? High frequency. How do you know it's a high and low frequency? Inside this period, from here until here. So how many cycles? 1 cycle. 2 cycles, right? 1, 2. You got two cycles here. But how about this one? How many cycles? 1, 2, 3, 4. You got 4 cycles, right? You got 4 cycle here. So 4 cycles in the same time period, that is considered a high frequency. So you can see this is low frequency represents 0, high frequency represents 1. So you have low, high, low, high, low, high. See? So they're changing the frequency to represent 1 and 0. High frequency is a 1. Low frequency is a 0. Yeah, it's simple, isn't it? So this is actually the process of modulation. Right? This process of modulation, how the two signals is being combined. And then phase shift keying. Okay? Phase shift keying, you are manipulating with the phase. Okay? This is actually one phase. You can see the phase is like this, starting like this, right? The phase is starting like this. But whenever there is a change from 1 to 0, you can start to see there is a change of phase here over this part. Okay, there's a change of phase. So it's not continuous, you see, because the phase change 180 degree. 180 degree change. From 0 to 1 as well, you see? The transition from 0 to 1, you can see this part. See this part also a change of phase. You know, it is not smooth. If it is smooth, then the phase is the same. But you see suddenly a phase change, you know, it is not smooth. So the phase has changed 180 degree. This is go back to your mathematics again. I think last time when you actually study mathematics, when you study circle, pi, and all those things, so you can start to see there is a phase change. Now one cycle is 2 pi, right? One circle is 2 pi. Okay, so this is to do with change of phase. So you can see that from 1 to 1, see from 1 to 1, this part here, is there any change of phase? I don't see any change of phase because it is smooth, right? It is smooth going through. So there is no change of phase. That means there is no change of value. And again, when you look at 1 change to 0 again, you can start to see this part is a change of phase again. See? So every change of phase indicate is a change of value, either from 1 to 0 or from 0 to 1, right? So you can see that there's a change of phase, indicate there's a change of a value from 1 to 0 or from 0 to 1. This part is a little bit confusing because this one you have to imagine it in a circle, right? In a circle. Okay, so these are the PSK implementation. So for the quadrature amplitude modulation, this is the advanced technique. Okay, it can actually carry more. This one here, you can see that from here, every time you only carry 1 bit only, right? You carry 1 bit, right? Every time 1 bit. But how about if I want to carry 1, 1? This one 1, 0. Let's say 0, 0, 0. Or can I carry 3 bits? This one 3 bit, no? Okay, compared to carry just 1. So you want to carry more bits, then this technique, quadrature amplitude modulation, is going to be very good. Because if you look at the diagram over here, okay, this is the value that you are carrying, the 4 value. You have 0, 0, you have 0, 1, you have 1, 0, and you have 1, 1. See, 4 value. They are using what? They are using the amplitude. Let me change the color again. Change to red again. Essentially go from the amplitude here. This is the amplitude. And the angle. They use two parameters to represent 2 parameters. They use the length and the angle to represent this value. That's why they can send 2 bits here. So this one is actually a little bit complicated because you have to play around with amplitude. They combine 2 techniques together. One is actually the amplitude, the other one is the angle. So you can see this one simple. This is 0 value, 1. BPSK is actually got 2 polar. This is the negative value. This is the negative value, and this is the positive value. This one only got positive value only. They do not have any negative value. So when this thing evolve into a QPSK, then you start to have something like this. This is the representation. And of course, if this is 4 point only, for QPSK only 4 point, Q stands for quadrature. Quadrature means 4. So it's actually equivalent to a 4-point QAM. Then later you can have 16-point QAM. Then the more extreme case, you can have up to 64 QAM. So more data you can carry in one period of time. Okay, 64 QAM is actually not the highest. People has been going for 256 QAM, 512 QAM, right? So the higher, there is something like a compression, you compress more data. Okay, You compress more data into the same period of time. Is it good? Of course, good. You see, because if you can compress from 1 bit to 2 bit, then your bandwidth increase double. If you can compress 2 bit into the 1 bit, 3 bit into the 1 bit location, then your data rate from 1 megabit can be upgraded to 3 megabit, 1 to 3, just like that. So now we can see this one. This one is using 64 QAM is 2 power of x equal to 64. So 2 power of what is equal to 64? 2 power of 6, right? It's supposed to be a 6, right? So if actually 2 power of 6 is equal to 64, this means this one can carry 6 bit. This guy can carry 6 bit of data in one slot. Compared to this one, only one on it. It's only 1 bit. This one carrying 6 bit. So which one is faster? So this one, this 64 QAM is actually 6 times faster than BPSK, right? So that is the logic behind. Then you may say that, oh, this is magic. Of course, I want to run this one as high as possible so that I can get a faster and faster link, right? A higher bandwidth link. No, they always come with a price. In this world, there is no free lunch, okay? If you want to have something good, then there is also always come with consequence. Consequence is that all these dots are actually so near to each other. You look at this dot, they are so near to each other, right? Compared to these two dots here. These 2 dots here in BPSK, they are quite far apart, right? But if you compare these two, compared to this one, then of course these two are very near to each other. When they are so near to each other, they can get confused very easily. That means 64 QAM will have higher data rate. Higher error rate as well. It's having higher data rate, at the same time, it's going to have higher error rate. So easily can experience data error. Okay, so that is the consequence. Everything comes with a price. Okay, so we only talk about the basic, but so when you go to more advanced communication system, then this sort of things is going to be very interesting. All right, so if you have analog signal to send, for example, your voice, I'm a DJ, I try to play some song, I try to sing over the air, okay? So these are the technique called analog to analog conversion. So usually we call it the modulation of analog signal. We're using AM, FM, and PM. And I'm not sure if any one of you still listening to FM radio. Okay, some of you, early morning, you like to turn on the radio and listen to FM, right? And you call it FM. Why? Because the voice that is being sent to you is using frequency modulation. If you live old enough, last time before, long times ago, the radio I did running on AM. Long times ago, I still remember, while I was still very young, then the radio are still using AM. Okay, AM and FM just a different technique. But today, FM is more popular because FM is more robust. It can give you a more robust, transmission. That's why people start to abandon AM. They move to FM. Okay, for your radio station broadcasting. That's why your radio station, you always call it the FM. People what my FM la, IFM la, whatever FM la. So it's basically what that means by they are using frequency modulation for all their broadcasting. And PM is not AM and PM, it's not morning and afternoon. So PM is pulse modulation, is another technique, but they are actually hardly used on radio broadcast. The radio broadcast is actually quite happy using this one already. Okay, this is what we call radio broadcasting, one of the example. Of course, their application is not only limited to radio broadcasting only. Their application can be beyond that. I just give you one example of your FM radio station so that you can understand the concept. But the application is not only for your DJ to actually broadcast your voice over the air. It's more than that. We can use it to send our voice as well. For example, telephone networks. Last time, when you actually call someone using the conventional old telephone. So they are also involving this process, what we call the modulation of analog signal. Your voice will be modulated by another analog signal and then carried by the analog signal to travel all the way to the destination when you actually make a phone call. So some of these analog signal modulation technique has been used as well. Okay, I think. Oh, and then all the analog signal that come with frequency, right? So they come with frequency, meaning to say that they will have been operating at a different channel, different frequency. And then for you to keep your data to transmit at a fixed frequency, we have to use a filter, right? We have to use a filter. We usually call it bandpass filter. Okay, bandpass filters to actually filter the frequency so that your data stay at a certain frequency. When you go to a different frequency, they can have different transmission already, right? So this is how they control. Okay, different frequency used for different application, different frequency being used for different channel. For example, your 1 FM running at 88.1, then you have other FM station running at different frequency. That's why you have to tune to a different frequency in order for you to receive that particular broadcast. Right. So same thing here. So analog to analog modulation, in conclusion, we have AM, FM, and PM. Same thing. So this is how the modulation process is happening. So you know that the original signal is actually in analog. So this one is also in analog as well. Then this is actually the composite. When you combine the two, this one plus this one, then you will get this one. Okay. So, and then this is actually the process how it is being put together, because analog signal always need to be generated by an oscillator. An oscillator is actually a device to generate analog signal. So they can combine, they can multiply them, so they can become this modulated signal. As simple as that. So frequency modulation as well, the same thing. Okay. Exactly the same. The concept is the same. So phase modulation also the same thing. It's just changing the phase on it. Okay. So in summary, these are everything. You just have to remember there's a difference between digital data, and then you have analog data as well. Two types of data. You must know where this data came from. Digital data came from your computer. When you open up a Microsoft Word file, you start typing something and you save. The moment when you save that file is called the digital data. And analog data come from where? The most typical example of analog data is your voice. Okay, when you want to send your voice over the internet. So your voice is an analog data. So in order for you to send digital data and analog data over the internet, then there are several processes that you have to carry out. First, you have to produce, because you want to send through the internet, right? The internet is actually a digital network. Okay? So first, you convert them into a digital signal. Then after that, from digital signal, you'll do digital to analog conversion. Okay? So that you can actually produce the signal that can actually travel in the network. So there's actually a process of digital data and analog data convert to digital signal. Then from digital signal convert to analog signal again, which is of higher frequency. So now you can see the different technique. And for analog to analog conversion, it is actually not being used in a computer network. Analog to analog conversion, it is used for things like the conventional telephone network, your FM radio station. So all these are actually using analog to analog conversion. It has nothing to do with your computer network. It has nothing to do with the internet, right? So this is actually the whole picture of it. I hope it is clear. So I think that's it for this learning unit. So I would appreciate if you have any question to ask. Is there any question that you would like to ask?
So far I got no question.
Sorry, no question. Okay, I see a question here. Okay, I have a question for the assignment. Since it is mentioned that it is a short report which consists of 6 to 8 pages, does it mean that 6 to 8 pages also include the cover page, table of content, and references? To me, I will make it flexible. Like, you don't have to be so rigid. Like, you want to include, you want to have all the content of like 6 to 8 pages of content. You want to be put your cover page, your references, all within that 6 to 8 pages is fine. The number of pages, I will not penalize you for anything of that. But just don't do too many pages. Okay? Just don't do more than 10 pages. No, I mean the whole thing. The whole thing, you just don't do more than 10 pages. So that'll be fine. So I'm quite flexible on that part. I don't want to be so rigid that, okay, you must, 6 pages on the content, 2 pages on table content, cover page, and all these things. I'll make it a little bit flexible, plus minus 10 pages. That is fine, right? So you don't have to worry so much about, you have to write so much on all those things. All right, another question, is it? Let's see. Let me look at the question again. Okay. Need to close this part. In quiz 1, there is a question about asking the frequency of infrared and microwave. We choose infrared higher than microwave. Infrared is having higher frequency than microwave. Yes, actually, infrared is having higher frequency than microwave, but it say it is wrong. Okay, never mind. I will take note on that. Maybe the answer that is being provided by the person who created the quiz, there's some issue with that. I will take note on that. But to be honest, infrared is actually closer to light. When it's closer to light, it will have higher frequency than the microwave. Okay, microwave is actually above 1 gigahertz, but infrared is actually in terahertz. Light is higher frequency, of course. I will take note on that. This is in quiz 1. Okay, thank you to note about that part. Then, but the quiz is actually just for your exercise. You see, you are taking quiz, it's really trigger your understanding. It's actually a self-test to actually help you to understand better. But you can raise that kind of question. I think that is very good. Now ours is actually perfect. Sometimes we actually click the wrong answer as well. We are all human beings, so we are meant to make mistakes. And sometimes the mistake are purposely be made by lecturers, just to let the student to discover and then to actually discuss about it. Okay? So that is quite common. All right, any other questions? I should stop sharing this one. Okay. Yeah. Any other questions that you would like to highlight? If no, anyone still not taking attendance? If there's no question, I think for those who have not get the attendance, I will share the attendance again. How do I turn this? Okay, so you can scan your attendance. Once you're done your attendance, then I think we will see each other again next week. And please bear in mind on the assignment that you're supposed to do. And of course, in May, we are going to have a mid-semester exam. In May, sometime in May, I think the date not yet announced. We're going to have a mid-semester exam, and it will cover Learning Unit 1 until Learning Unit 6. Just to give you a head-on on the mid-semester exam, okay, so that you can prepare. If some of you would like to prepare, yes, you can start preparing. That will be in May, but the actual date will be announced again. Thank you very much. And I'll see you again next week.
Thank you, sir.
Yeah, see you.
Thank you, sir.